Okay, this question's a little tricky too. I had to do it in two parts. So you got the reaction time is a half a second. So, right, the girl is driving her car, she sees an obstacle, and then it takes her 0.5 seconds to just put it on the brake. So she continues to travel for a certain distance. So it's important to find the distance that she travels first. Now, again, what I did, by the way, is, I wrote t equals 0.5 seconds. A is negative 0.6 seconds, or meters per second squared. Her initial velocity was 20 meters per second. Right, I know these things. Now what I want to do is I want to see if I can solve this. So the first thing I would encourage you is find how many meters she travels before she hits the brakes. So she has a half a second time, and again, just V is d over t. You can find d because you know V and t, right? Once you know that, she then has traveled a certain distance, right? The obstacle is 50 meters in front of her. I wouldn't plug that in, but she'll travel. Let's say that she travels, 15 meters in this time, and there's 45 or 35 meters left. Then what you want to do is solve for the distance using an acceleration equation. So look at your three equations, figure out which one's going to make the most sense, and you want to solve for the distance traveled, knowing the acceleration. Once you know the acceleration, hint, hint, which one did I use? I used the equation, I used the V final. This is the second equation after I subtract. Squared equals V initial squared plus 2A delta x. And so you know what the A is, negative 6. You know V initial, that was, I think, at 20 meters per second, something like that. Final is 0 because she's trying to come to a stop. And you can solve for the delta x. And if that's greater than, what it was, 35, I'm making that number up. That's not really right. Whatever that is, then you can determine if indeed she can stop the car in time.